much as 70% of Korea is covered with hills and mountains, and the geographical factor left the land with a lot of curves on railways, keeping trains from speeding up. As things stand, adopting Tilting Train Express was found to be necessary to fit the nation's geography so that trains do not have to slow down even on curves. Korea has 3 major trains. KHSR 350X shows off its maximum speed of 350 kilometers per hour, and its commercial operation is targeted for the year 2009. KTX and Saemaul trains now run on commercial main lines at the speed of 300 kilometers an hour and at 140 kilometers an hour respectively. We needed to come up with some mid-fast train which can buffer the whopping speed gap between KTX and Saemaul train, and that is how we designed TTX at the speed of 200 kilometers an hour. While Saemaul train is diesel-powered, causing serious air pollution with noise and smoke, TTX is an electric train that can reduce contamination in the environment. A work of electrifying railways is being driven worldwide, and Korea is also making a strenuous effort for the project. The TTX can save our life and environment along with energy efficiency. The gist of TTX is the tilting technology that enables the train to speed up on conventional lines with only minimum improvement of the railways. The principle of the tilting technology can be explained by taking a motorist who inclines the car to the left or right to rush through sharp curves and high speed without overturn. The existing trains had to slow down extremely on curved tracks to overcome the centrifugal force. However, TTX tilts the car body toward inside curves without much reduction in speed, and the car body goes back to its normal position when the train clears away the curved areas. If we take a closer look, the tilting train detects on curves with the help of a tilting sensor. When the detection takes place, electromechanical actuator controlled by computer tilts it toward centrifugal force, helping the train clear away the curved areas without slowing down too much. TTX technology has brought an innovative speed up on conventional lines, and the breakthrough does not stop here. Development of carbon filter composite reduced the overall weight of the car body by 30% from the existing trains and helped with energy conservation as well. Followed by steel and aluminum for material of car body. The debut of the composite material is notable in aspect of manufacturing, which enabled the seamless formation of car body for the first time in the world. On top of that, other technological features with the nation's originality include tilting equipment for the passenger's ride comfort and speed up on curves, bogie system with concise steering device, and electric equipment for the maximum speed up to 200 kilometers an hour. The development of TTX is particularly significant for the nation's achievement of electromechanical controlling system for the train on its own. Tilting trains in Sweden and Finland feature hydraulic cylinder, while Italy and Spain adopted electromechanical actuator. Geographically, these countries have a lot of rocky mountains with many ins and outs around coast areas, and opted for tilting trains for speed up on conventional lines. In the midst of devoted efforts to develop tilting trains in so many countries, Korea has tenaciously worked for TTX with electromechanical actuator and plans to put a test train on main lines in 2007 at design speed of 200 kilometers an hour with commercial operation in 2009. Accordingly, the opening of Gyeongbu lines has brought small towns closer for mutual benefits, contributing to balanced developments between regions. By using conventional lines, we can save costs for railway construction and maintenance. And more than anything else, we can protect the natural environment, which can be threatened by laying straight railroads. TTX is environment-friendly driven by the method of electromechanical tilting actuator. The electric-powered TTX also conserves energy and cuts the travel time by 20%, with the speed up on curves while providing passengers ride comfort. All of the above, Korea has combined every possible technology to develop TTX on its own, and now we have an eye on overseas markets with a state-of-the-art technology. It will enhance the image of Korea as a nation with high-speed rail, and the country will well deserve the title. Challenges for progress and continuous efforts are driving forces of KRRI. Researchers with Conventional Railway Project Group, KRRI, are striving to meet their goal of putting TTX trains on conventional lines at design speed of 200 kilometers an hour by the year 2009. The geographically tailored and environmentally friendly TTX can meet the railway standard of the Korean Peninsula. Each and every one of us needs to show our sincere interest and encouragement. Moving a step forward, TTX will well prepared to be put on Trans-Korean railways when the two Koreas are reunified in the near future, serving the demand in the mountainous areas of North Korea. Toward the north, toward Eurasia, and toward Europe, TTX will stretch itself to the world for the passengers' faster, safer, and enjoyable ride. Over a century has passed in the Korean railway history. Another century down the track starts with KRRI, and we promise a brighter future of railway.